Hey, and welcome to this lesson, which is all about cleaning up Blueprint code and looking at different ways we can collapse our code down by using Blueprint functions, macros, and collapsed graphs. Okay, so in the previous lesson, we implemented this apply damage function into our projectile class. When our projectile hits the player, it will call this function and apply damage to the player. And what this really means is that it will call this event any damage inside our player pawn blueprint class. Now currently when the player is damaged, it just prints a message to the screen displaying player pawn damaged. But we want it to follow the same behavior as when the player falls off a level and passes through our level restart trigger. We want it to fade out and restart the level when the player is damaged. So what's the best way to do this? Well, just like I said, we're already doing this with our level restart trigger. Let's come into our level restart trigger blueprint. We already have all the code for restarting the level and fading out the camera here. It's just after this branch here. I'm going to select all of these nodes, but I'm not going to copy them. We want to avoid having the same bunch of nodes and code in multiple different places. We really want to avoid copying and pasting our code everywhere. So I'm going to hit Control X to cut the code. And I'm cutting because I don't want to copy it. If we copy it, you are repeating code somewhere. So just always think when you press the copy button or Control C, why are you doing this? Okay, so I'm cutting it. I'm going to come back to my player pawn and I'm going to paste it in after my event any damage here. I'm going to remove my print string and I'm going to replace the print string with a do once node. I'm going to hook up the execution pins just here. And we're using a do once here because we only want the player to be damaged once and then execute the fade out and level restart. We want to avoid the opportunity for this to execute multiple times as it will reset our camera fading and appear quite jarring. So this will help us avoid this. Now if we come back to our level and we play from here, we can see now if we get hit by a projectile, the level fades out and restarts. But if we roll off our level, we can see now nothing actually happens, and this is because our level restart trigger has no code going on other than this check with a branch here. So your challenge right now is to make it so when the player enters the level restart trigger, it will result in the event any damage executing on the player pawn. So pause here to give this a thought and then attempt the challenge, as this will fix our current issue with the level restart trigger. Then once you're ready, come back to the lesson and we can resume. Okay, so when the player overlaps this level restart trigger actor, we want to execute the any damage event on the player pawn. So to do this, we need to apply damage to the player pawn, and we can do this by calling the apply damage function, and we can use the return value on the get player pawn function here as the damaged actor. And we can hook up the true output from the branch to this. And we want to make sure that the damage value is above 0 to make sure that the damage is actually applied to the player pawn. Okay, now let's come back to our level and hit play, and let's roll off our map just here. And we can see that the game fades out and restarts and works as expected. But we can simplify our code here. We can make it so if any actor enters this trigger box, we can apply damage to them. So we can actually remove the branch and this equal check here and the get player pawn function, and we can just use the other actor going straight into the damaged actor here. And look, if we come back and hit play, it works the exact same way but with less code. So whenever the player receives damage at any point, we execute this code that fades the camera out and restarts the level. And this will happen for any other actors that we create that call the apply damage function to damage the player pawn. Now I encourage you at this stage of the course to start exploring in between lessons by creating your own blueprint actors that can cause damage, and make sure to post your results to the Game Dev TV community forum. It'll be really interesting to see what you and other students taking this course can create. Now we want to clean up this code after the damage event in the player pawn here. I want you to try and encapsulate and collapse this down. So your challenge right now is to explore the different options of collapsing your code. Select the nodes after event any damage in your player pawn and right click on them, then try different methods of collapsing your code. So pause here to have a go at this, then come back to the lesson and we can explore this together. Okay, so we want to select all of our nodes after our event any damage, and we want to take a look at collapsing these nodes down. So we can right click on one of the nodes we have selected and we can see the different options for collapsing our code down. Let's start with collapsing it to a function. It's not going to allow us to do this because we have a delay, and functions cannot contain delays. So what else do we have here? Well, we can collapse nodes, and when we do this, it collapses all of our nodes here into a single node, or this is a collapsed graph, so it's kind of like a mini event graph in a way. Now you can see our event graph's actually gone, but we can come back to the event graph just by hovering over event graph here, and we can click it to come back. Now I'm going to undo by hitting Control Z. I'm going to keep doing that till I get my nodes back, and we're going to take a look at the final option, which is collapsing our nodes down into a macro. So it does allow us to do this because macros can contain delays, and when they do contain delays, they have this little symbol on them showing us this clock timer, letting us know that there is a delay inside here. So I'm going to stick with a macro, and macros are reusable when collapse nodes aren't, so that is one thing to keep in mind when using a macro. I'm just going to rename this macro to restart level. Okay, I'm going to hit compile and save, and now let's come back to our level and let's just make sure everything works. Let's start with the cannons. If we play from here and roll into one of the projectiles, we should see that we do restart the level after we get hit, which it does, and then if we roll off again, it should also restart the level, which it does. Okay, but there's a problem here just with our level trigger that we're using, this level restart trigger. It's not really a level restart trigger anymore because it's not restarting the level, it's causing damage to the player. So we're going to rename this just before we move on to the next lesson. This is going to be named BP underscore damage volume. And the folder it's in can also be renamed to volumes. Okay, so that wraps up this lesson. We now know how we can collapse our blueprint code, not only down into functions, but also down into macros and collapsed graphs. In the next lesson, we're going to take a look at creating a win mechanic so players can complete a level and move on to a new level. Hello and welcome to this lesson, which is all about macro libraries. In this lesson, we're going to learn how we can avoid creating the same macro in multiple blueprints by creating macros inside a macro library. Okay, so we're going to start this lesson by creating a volume that we can place anywhere in our level, and we're going to make it so once the player overlaps this volume, we run some code to check to see if the player has collected all the crystals in the level. And if they have, they will complete the level and move on to a new level. So let's create a new actor inside our volumes folder. And let's call this something like BP underscore win volume. You can call yours anything you like. It could be complete level volume or next level volume. But once you've named it, let's open up this actor and let's make it a volume just by adding a box collision component. And we can just call this something like trigger. And we can make the trigger visible at any time by scrolling down on the details panel when we have it selected, and we can uncheck hidden in game. And this is just to help us out for now. You can change this anytime if you don't wish to see it in your level. And this is all the components we need, so let's switch over to the event graph and start coding in some behavior for it. Let's remove the begin play event and also the event tick, so we're just left over with the event actor begin overlap. Now we can check to see if the other actor is equal to the player pawn, and then we can use a branch to get the true and false result from that. But this is all feeling a bit familiar, right? We've already done this inside our crystal blueprint. We have this macro here that's named isPlayer, and inside here we have the exact same code. And remember, we want to avoid any repeating code we may have. Now the issue with this macro is that it exists inside this crystal blueprint, and we cannot use it inside our volume we've just created. But this is annoying, right? This is a pretty simple macro we have here that we would want to reuse many times across our blueprints. And we don't want to have to keep repeating the same code from this macro in every blueprint we create. We always want to avoid repeating code. So how can we avoid this? Well, we can create a macro library. Macro libraries can be used to create common macros, and macros from a macro library can be reused across different blueprints, which is different to creating a macro inside an active blueprint like our crystal, as we cannot use a macro from one blueprint in another because the macro only has scope to its class, meaning we cannot reuse this isPlayer macro inside any other blueprint because it only exists inside the crystal blueprint. This is what I mean when I say it only has scope to its class. But macros from a macro library can be called and used in any actor blueprint. Let's take a look at creating a macro library. Inside our blueprints folder, let's create a new folder called libraries. And inside this folder, we can create a new macro library by right-clicking and coming to the blueprints category here, and we can select blueprint macro library. Now when we do this, it looks like we are creating a new blueprint, which seems a bit confusing, but this is really asking us about the scope of our macro. It says pick parent class here. So as an example, if we chose pawn, we would not be able to call macros from this library inside any actor blueprint. We would only be able to call it inside any blueprints that inherit from the pawn class. But if we chose the actor class, we would be able to call it inside actors and also pawns. And the reason we can call it in pawns as well is because the pawn inherits from the actor class. The pawn is an extended class of an actor. But our crystal and volumes are both actors, so we're just going to select actor here and we can name the macro library. This isn't naming the macro, this is naming the library which can contain numerous macros. I'm just going to call mine cc for crystal cavern underscore macro library. And we can double click the library to open it. And when we do this, it creates a new macro for us straight away. We can see this in the My Blueprint tab, which is in the top right inside this interface. And you can see here it's asking us a name for our macro. We can call it isPlayer. And we can add more macros here by hitting this new macro button, and we can delete them by selecting them and hitting the delete key. So this is how we add new macros. And on the details panel, we can add inputs and outputs just like a regular macro, and we can even start coding inside the blueprint graph, just like it's a regular blueprint. So your challenge right now is to take a look at your isPlayer macro from your crystal blueprint. Then create the same macro in your macro library. And once you've done this, remove the old isPlayer macro from the crystal blueprint and delete it from the My Blueprint tab. Then try searching for the new macro from your macro library and add it to the event graph to replace it. So pause here to attempt this challenge, and then once you're ready, I'll walk you through the process in a few moments. Okay, so inside our crystal blueprint, we have this isPlayer macro. I've recreated this macro inside my macro library. But notice how inside the crystal blueprint, the input execution pin doesn't actually have a name, but inside the macro library, my macro does have a name and it's named new parameter. Now I can't actually remove this name. It says the name cannot be empty. So how do we remove the name on the execution pin? Well, you just need to name the pin execute, and the engine will read that and remove the name for you visually on there. I've also put my macro inside a category named Crystal Cavern Macros. So inside my crystal blueprint, I'm going to come back to the event graph. I'm going to remove this isPlayer macro and delete it from the My Blueprint tab. And I'm going to right click and scroll down to the new Crystal Cavern Macros section and call the new isPlayer macro. If you don't see a macro in your category that you've created, just make sure to save the macro library because it needs to be saved in order to apply the macro to its new category. Okay, now we can just hook this up with all the pins just like it was before. And one thing to note here is if you double click on the macro, it will take you to the macro in the macro library, and you can select the macro and you can even change the color of the macro so it looks different in the blueprint editor here. But just be careful with the colors here, not to confuse them with any other functions inside the engine. So we're now using our new isPlayer macro, and the cool thing here is that we can reuse this inside another blueprint. We can remove the code from our win volume blueprint that we started creating at the beginning of this lesson, and we can now call the same macro. Okay, so that wraps up this lesson. In the next lesson, we're going to take a look at how we can get all the crystals that exist in the level to see if the player has collected them all. So when you're ready, I'll see you in the next lesson.